Hi there, today we're going to be making a little project to make you see just like a bat. We're going to need a couple of components for this, so we'll need an ultrasonic distance sensor, a vibration motor, a 1.2 and a 2.2 k ohm resistor, lots and lots of jumper leads, and of course a breadboard. Here's the circuit we're going to be building, so you can either pause the video and set this all up now, or you can watch me build this in absolutely record time. First we take our distance sensor and place it into the breadboard. Next I'm going to place my two resistors, the 2.2k resistor running to the ground and the 1.2 connecting to it. I need a jumper lead connecting the VCC pin to 5 volts on the Pi. Then I connect the trig pin to GPIO 4. Next is a jumper lead to connect the echo pin to the 1.2k resistor, and from the other side of the resistor I link into GPIO 17. I finish off connecting my ultrasonic sensor by linking the ground to the ground on the breadboard and ground from the breadboard to the ground on the Pi. Lastly, I connect my vibration motor to ground on the Pi and also into pin 14. Now we can write code to test it all. First, I need to import an input device and an output device from GPIO 0. I'm also going to need the time and sleep. Next, I set up trig on pin 4 and echo on pin 17. And finally, I need to let it sleep for 2 seconds. I need a function to make my sensor work. The first thing I'm going to do is I'm going to send out a pulse of ultrasound for about 10 microseconds. The echo pin should then become active straight away and I can instantly start timing, so I'll record the time. Then I'm going to wait for the echo pin to receive the echo back off the object the sound's reflecting off, and I'll record the time again. I'll add in another sleep here just to let my ultrasonic sensor rest, and then I'm going to return that duration, the difference between the two times. Next I need to calculate the distance the object is away from the sensor. I know that the speed of sound in air is 343 meters per second, and I remember from my school day physics that distance is speed times time. I'm going to need to half that because the sound has to travel to the object and back, and then I can return the distance. To finish off, I can get that duration. I can then use that to calculate the distance that the sound has travelled, and then I can print out that distance to the console. Now if I save and I then run this script, I can see that printing out there is the distance that an object is from the ultrasonic sensor. Now I can bring in a PWM output device and I can set that up on pin 14 to control my motor. And now I need to calculate what value to give the motor, so I want to take that distance and turn it into a floating point number between 0 and 1. To do that I use this clever little bit of maths just to remap the values, and then I'm going to return that value, which is the amount that my motor is going to need to vibrate. Down in this while loop now then I can tell my motor to vibrate by that amount and just remove that print. So with it all tested on the breadboard, I'm now going to solder it all together, and then I'm going to take my ultrasonic distance sensor and this old glove I've got here. I'm going to attach my ultrasonic distance sensor to the palm side of the glove on the outside, and I'll have to sew that on there. And then I'm going to take my vibration motor and I'm going to put that on the inside of the glove, again on the palm side, and I'm going to have to sew that in there. And then lastly, I'm going to use a Pi 0 because it's a little bit smaller, and what I'm going to have to do is I'm going to have to sew my Pi 0 onto the wrist of the glove at the back here, and then I can give it all to my little boy to test out.
Here we go. Keep your eyes closed.
You're getting close. Not that close though. Okay, now you're getting close.
So there you go. That's how you can use echolocation to see just like a bat, using nothing more than a sensor, a little motor, couple of components, and a Raspberry Pi.